All right. A little bit of an internet snafu there, but we've got it sorted, I think. So I am Grant Skinner. I run G Skinner, which is not a very creatively named company, but we make do. We build interactive experiences for some pretty interesting clients. And I also am the creator and sort of principal developer on CreateJS, which will become important in a moment. And CreateJS is an open source suite of libraries targeted at making really rich interactive experiences. So it's comprised of 4 libraries right now: Easel.js, which is fast 2D graphics; Tween.js, which is animation; Sound.js, which is audio, of course; and Preload.js, which is asset management and preloading. This will become important in just a second. So I'm going to talk about a project that we built with these libraries called the Dragon Age Interactive Story Summary. And how many people here have played one of the Dragon Ages? All right, a bunch of you. For those of you who haven't, really quickly, Dragon Age is a series of games. It's a fantasy RPG, has a lot of the sort of standard elements for fantasy RPGs, dragons and wizards and magic and swords. But it's also really well known for having a lot of lore, a really well built out world, and a really well built out universe, and having a really strong storyline. And one of the kind of unique things about it is that the choices that you make through the game, be them through actions or through dialogue, have a real impact on the world that you're playing in. And they affect, the endings that you see. They affect the types of plots that you're exposed to. And to make it even more interesting, the decisions that you make in one game can actually move forward and affect the world that you play in subsequent games. And so as BioWare got ready to release Dragon Age Inquisition, which is the 3rd game in the series, they wanted a way for their heavily invested fans to be able to come back, look at the choices they'd made in previous games, kind of review those choices, remind themselves of what they had done, and maybe tweak some things so that as they went into the next game, they had a world that they felt comfortable with and that they felt reflected their personality. And so they started working on something called the Dragon Age Keep. And so the initial version of this was this tile-based interaction. This is still what you'll see if you go there now. This tile-based interaction that sort of lets you look at these different categories of decisions, and you can click into them and alter the decisions, and it has this whole world state engine behind it that makes sure that you don't have conflicting decisions, right? If character A dies, you probably can't fall in love with them later on. I mean, you could, I guess, but it might get a little weird. So as they started building this, they realized that while it was a very effective interface, it wasn't a very engaging interface from sort of a cinematic perspective. And they came to us with a brief. They said, we want to be able to summarize the in-game choices that our players have made. We want to do that in a really cinematic way, and we want to do it online. And people need to be able to do this on their mobile devices, on their desktop, or even just through their console browser, as they're playing the game. We said, yeah, that sounds really intriguing. We've worked with BioWare before. They're a great client. They tend to have really fun projects to work on. And they're also pretty technical. So we went into this meeting. This isn't the actual meeting. These are just actors that I've hired to play, people in the meeting. I'm being played by the handsome fellow on the right. And BioWare will be played by this guy that kind of looks like Stifler from American Pie over on the left. I think this session is recorded, so it's important that I say that the people we worked with at BioWare are actually a lot more attractive and intelligent looking than that guy. So we come in, and they're playing hardball. They're like, we should let you know up front, this is a multi-vendor bid. We're going to show this to some other companies, hear how you guys might approach some of these problems, and then we'll award based on competency and price. And we're like, well, we don't normally bid, but this sounds interesting, and we have this established relationship, so yeah, let's do this. So this meeting turned into one of those beautiful client meetings that if you had handed the client a script at the beginning of the meeting, you couldn't have made the meeting go better. Again, they're pretty technical, so they had done some due diligence, and they started asking us pointed questions. And they were like, we've been doing some research. We know that we need like a really good, solid 2D graphics and animation setup, and we'd be interested in what you guys would use for that. I was like, well, we happen to have built Easel.js, which is one of the most popular libraries out there for 2D graphics, and Tween.js, which is one of the most popular libraries for animation. They're like, well, that's good, but what about audio? We've been trying to get audio to play consistently across all these different devices, and it really seems kind of tricky. Some of them don't support web audio, and we need to do audio tags, and it doesn't seem very reliable. I was like, well, I don't want to brag, but we did build Sound.js, which is probably the most popular library out there for playing sound online. So I think we got that one covered. And they were like, You could tell they're still trying to be cool, so they're playing it off. And, well, what about assets? I swear to God they asked about assets. They're like, what about loading these assets? This is hard. You can't do it reliably. We want progress bars. We want people knowing what's going on. How are we going to solve that, tough guys? And I was like, well, we happen to have built Preload.js, which kind of solves that problem too. Okay. So you've got the libraries. Maybe you guys have the technical chops, but we're going to be producing a lot of animation here, and we have not found a good process for how to actually produce animation for the web, right? It tends to be this pretty manual process that involves a lot of technical know-how. So they're like, what's your process? What's your tools? It's like, well, I'm probably starting to sound like an asshole, but we didn't build Flash, but we actually built the tool that exports Flash to HTML5 canvas. So we know how to do that as well. So at that point, everyone jumped up. They said, you guys are awesome. We said, thanks, you're cool. We ate cake, and we had a dance party. Whoops. Dance party, woo! I might be exaggerating on that last part, but regardless, I'm not sure they went to any other vendors. They basically said, yeah, let's do this. So we signed a contract. We got to work. So I want to show you guys what we actually built. But first, a quick warning. If you identify with the guy in this photo, this might not be the talk for you. If you're a crotchety old Flash person, I'm going to show you this, and you're going to be like, I could have done that in Flash. And you would be 100% right. I could have built this project 10 years ago in Flash, and it would have been fine. However, we needed to make this thing work on mobile. We needed this to work on console browsers. It had to work everywhere, and Flash just really wasn't an option. So, we can wail in the dark about the technologies we love. The director developers had the same moment when the Flash developers came along. But the point of this talk is that we can finally build this type of experience on top of the web stack again. 4 years ago, this project would have been impossible. 2 years ago, it would have been probably fiscally impossible. It would be a very expensive project to produce. Today, we were able to build this project and do it in a very limited budget. I think this project cost us almost exactly the same, maybe even a little less than what it would have cost us to do it in Flash. And at least for my company, that's a major milestone for us, because we used to take any Flash-like experience and say, oh, HTML5, let's double or triple the budget, because it was way harder to produce this type of content for that environment. So this isn't really about building something you couldn't do in Flash. This is about, we're finally at the point in the modern web where it is financially viable to build rich content without a lot of struggle. And to me, that's exciting, because we've made a lot of compromises over the last few years. We've said goodbye to Flash and tried to figure things out on the web. So let's look at the actual experience. Hopefully this works. Demo mode on. So this is the Dragon Age Keep. You can see I can click through these tiles, and I recruited a dog. And if I wanted, I could say, actually, no, I didn't recruit this dog, and I can change my answers. So this is sort of the application interface onto the choices that I've made. The piece that we built is the interactive story summary, which lets you come in here and basically play back your world. So I'll just let this run.
If you believe the stories, mankind's pride gave rise to the Darkspawn. Countless in number and toxic to all life, Darkspawn search endlessly for an archdemon. When they find one, Darkspawn armies surge up from their corrupt barrows beneath the ground, and a blight begins. Grey Wardens are the only warriors capable of destroying an archdemon, and history always honors the one who sacrifices all to kill the beast. In the fifth blight, the Warden was the hero of Ferelden. Youngest child of Ferelden's powerful Terran Kusland. Betrayal saw the Kusland's ancestry.
So this goes on and on and on. These are very in-depth games. I think sitting through the first two is about half an hour to go through all of your decisions. And it has a very dedicated fan base. One of my cousins is extremely into this game, and she comes on here and changes the world state constantly and then watches
the hero located.
So it's not just a static playthrough. There's also reviews of the decisions that you've made. So this will come up in just a second. I'll just let this play.
Urn containing the sacred ashes of Andraste, which were said to cure any ailment. The urn was protected by ancient traps, tests of will, and a dragon-worshipping cult.
So in this case, there was a choice that was made. And so right now I'm watching the outcome from the choice I actually made in the game that's been imported into this system. But I can actually say, well, I don't actually like this outcome. I want to change this outcome. I'm going to go for the bad, the evil
the urn
choice.
Was protected by ancient traps,
and it'll go back and it'll review a little bit of the story with you, and then it'll present the outcome of that choice.
To its own ends. The cultists encouraged the hero
so this
to
time we get the
ashes with
dark
dragon's blood,
version of the outcome. And this one is a fairly minor change in terms of how much the animation changes, but some of them create quite in-depth differences. It's also, the whole system is supported by a world state engine that basically lets us make sure all the decisions you make as you go forward always propagate through into both decisions later on in that game as well as decisions in the next games. So that's a quick look at what we built. An immediate question might be, well, why not do this whole thing with video, right? That would be sort of the immediate naive solution. And in some cases, it would be maybe the ideal solution. Obviously, we're a little bit more limited in the graphics that we can use, the animation style we can do, but it was a perfect fit for what BioWare came to us with. And you'd run into some pretty major technical issues. Not all browsers right now allow you to sequence video, at least not client-side, right? iOS on a mobile device doesn't really let you do anything with video. You play it, you jump out of the stream, you're back into an interface. And we wanted to be able to stick all of the interaction in line. We wanted to be able to sequence these animations seamlessly. And we couldn't have done that without either a pretty major server investment or just abandoning those platforms or having sort of an alternate experience for them. As we built it, we also realized some additional benefits from taking this approach. One of the ones that I'm most proud of is size. If you ignore sound, which is sort of like a given, a flat cost, that these animations are about 1/100th the size of 720p video, and they will scale to any size we need them, including well beyond 1080p. We can play these back at 4K. We also saw benefits in localizing this content. It's completely resolution independent, and we were able to solve some issues around aspect ratio that would have been a lot harder if we were doing this with video. I'll talk about some of these in more depth as I go through. So let's look at how we actually did this, what the process for creating this content was. So BioWare would provide us with tile art. You know, they were doing all these tiles. They'd provide us with layered AI files, Illustrator files. We would take those Illustrator files, and we would do some prep work on them. We'd sort of simplify a few things. We'd watch out for specific use cases that caused problems when we were bringing it into Flash. And, you know, work with it inside of Illustrator. We then pull that content from Illustrator into Flash, preserving all the vectors and all of that type of thing. We'd obviously use Flash to animate the content. And then we'd use the HTML5 canvas exporter for Flash to just dump it straight out to CreateJS and, of course, HTML5. And this is great. It meant that our animators were able to work in an environment that they were completely familiar with. They had access to all the features that they were used to using. They could use masks, they could use motion guides, you know, obviously tweens, embedded graphic symbols and movie symbols. They didn't really have to learn anything new to just get in and start producing content. And this is really what we see our job as, is facilitating this creative output. You know, this shout out to Pulp, who was our animation partner in this. They did want some things that didn't come for free. We realized pretty early on that a lot of the animations were pretty flat, and they didn't have quite as much sort of depth to them as we would like. And so one of the things that we did for them was we built a virtual camera system. So they were able to basically take this well, let's look at this one. They're able to take this camera object that we created. Let me just resize this thing here, and they're able to actually move this thing around. They can do everything from move it around to pan. They can scale it in order to zoom. They can even apply motion guides to it to sort of put the camera on rails. So for example, you know, here you can see this camera following this motion guide up to give us this kind of like down and up movement of the camera. You know, as an example, I can run this.
Fighting spread swiftly through
while this one is very subtle, you can see this slow pullback on the camera. And that's achieved just by scaling this camera object, right? The middle square is showing me what my primary focus for the camera is going to be. And so as the camera gets larger, we're basically pulling back on our zoom. I can exaggerate this massively and demonstrate my complete lack of animation skill. We'll start with this. This is dramatic, right? Yeah, right on that guy's face. We'll start right there. So if I run that now,
fighting spread
we get this
through the
super
city.
dramatic. I think this is the way we should have launched, actually.
Many of them
we got this very dramatic, pullback
Templars
onto the
their
view.
Swords on mages who rebelled and on those who did not.
We also, of course, put some work into building them a little testing framework. Once we had the camera in there, they weren't able to as easily see what was going on just on the timeline. And the camera was sort of this extra piece of code. And so all we did was on the timeline itself, we wrote a teeny tiny little chunk of code that basically just said, if I'm not index.html when I start up, load up index.html. And then our index.html file had this testing framework built into it. So our publish process never really changed at all, but we were able to load up into this testing framework that gave us things like the camera, letting our animators preview the camera. It would read the labels from the timeline so that it would know, it would allow them to jump between different sections really easily and change choices. And it also would let them do things like pause and like fast forward and rewind through the content, which turned out to be really handy for them as they were trying to isolate what was going on in their content. Okay. Taking this camera approach let us tackle aspect ratios as well. It turned out really well for this. We basically have this, we're deploying on multiple different devices. We don't know if we're playing back at 4:3 or 16:9. It could be just about anything. And we really wanted to fill as much of the screen as we possibly could. We wanted to avoid letterboxing. So what we did is we said, okay, this camera, as you're doing your animations, make sure that everything in the one-to-one box, this main square in the middle, looks really great. That's where the focus is. That's where the action is. If the aspect ratio changes and gets wider, then we'll expand the camera view out to these two ticks on the sides. So it's going to wind up looking like this at 2:1. Then, as the camera moves side to side, we're going to calculate how close we're getting to one of the edges, and we'll dynamically shift the focus over to one side. So as it moves over to the right, you can see that the camera adjusts, our focus adjusts to take in more of the view so that we're not hitting an edge at any point. And our animators don't need to think about this at all. They just need to make sure that the those outside lines never, the square never leaves the action. And then, as we move left, our focus shifts over left. So we're always guaranteed that our area of focus is on screen, and our animators didn't really have to worry about what 2:1 was going to look like. And then anything in between was just math. We just figured out how to display that correctly. And this worked out great. It really solved a lot of issues for us. We also kind of later on stumbled onto an advantage that we never really took advantage of in the project. We put together a showcase for our own site for this project, and our site obviously has to be responsive. And we were running into this issue where when we were on a desktop mode, a landscape mode, we wanted the focus of these animations to be off to the right. And when we went into sort of a handset or portrait mode, we wanted the focus to, now it's not even, there we go. We wanted the focus to move more to the center. And we struggled with this until finally one of our designers was like, is there any reason we can't just have a second camera? And we were like, oh, yes, of course. We can just switch cameras. I feel like this is something that we possibly could have taken advantage of within this experience and never really got around to. But it opens up some interesting ideas, I think. Okay. So another really critical thing was performance, right? We needed this thing to run everywhere. Handsets aren't too bad these days. Consoles, though, are actually really slow. It's hard to get things to run well on consoles. And it became clear early on that this was less a code problem and more a content problem, right? We could optimize things, but if you had a ton of complex vectors or a lot of radial gradients or a lot of masks on screen, things just slowed down. And there was nothing that we could do in code to really fix that issue. So we had to find some way of empowering our designers or our animators to create performant output. One of them was just taking advantage of Cache's bitmap, which is, Flash folks will be familiar with, but which is also supported in Easel.js. It basically just let our animators choose specific pieces of very complex vector content to say, hey, this is going to pre-render into a bitmap, and then it'll just get moved around on screen. So it saved a lot of rendering time. We had to be careful with that, though, because handsets were such an important part of our market. And every time you do this, you take up a little bit more memory. So doing it too often, you overload the memory, you're right back to having major performance problems. We realized it wasn't really fair to tell our animators to make this performant without giving them some way of actually testing things. And our initial attempts at this were pretty weak. Early on, we had them just basically run this content. Let's see, what do I want to run? I'll run this. Basically run this content, fire up activity monitor, watch the CPU usage, and if they hit something that was taking up too much CPU usage, they could basically track back to individual frames, and instead of stopping rendering when they hit a frame, we would continue to render, and that way they could stop on that frame and look at it and say, oh, this is using too much CPU, and adjust the content. This wasn't a really great solution, as you can imagine, right? It's very manual. It's pretty laggy. It takes a long time for Activity Monitor to actually catch up with the content on screen. And so it became clear that we needed a better way of approaching this. And so partway through the project, we put together a performance test engine that became extremely successful for us. Our users, or our animators, were able to open up their test harness, click this little link, and then they could resize to whatever size was appropriate, right? Because different devices are going to play back at different sizes. We want to be able to test, from very big to very small. And when they thought they were at the right size, they could hit space. We run through this animation, and we play back every frame as quickly as we possibly can, and we log how long that frame took to play back. And we, chart it out on the bottom. The middle line here represents our target time, right? That's 16 milliseconds. So it means that on desktop, it's going to run at a full 60 frames per second. And it means that on mobile handsets, it'll generally hit about 30 frames per second, which we thought was a pretty good compromise speed, right? 30 frames per second is still like video playback speed. And we made it so that they could come in here and look at this and be like, well, there's a couple of little glitches here. Maybe that coincides with the lightning. So maybe that's something we should look at. This guy actually has a mask on him, and we know that masks are expensive, so maybe we take a look at that. We get a little bit of a slowdown back here. It seems to be when we're bringing in all these gradient lights, so maybe that's something we have to worry about. But our big problem is here, which is where we have the masks and the gradient lights. So maybe this is something that the animators have to go back and spend a little bit of time on and see if they can make it run faster. And this worked out really well. We were able to take a lot of this content and make it run a lot faster because the animators finally had a visual tool that they were comfortable with that could really isolate where there were problems. The other nice thing about this tool was that, unlike using Activity Monitor, which is very dependent on the operating system, this we could run anywhere. We could stick this on a console browser and do a performance test there and see what was causing problems for us. And so we were able to isolate issues on pretty much every platform. That doesn't mean that we didn't do some work on the code side to make things run faster. This actually prompted me to go back and do an extensive rewrite of our graphics engine, our vector graphics engine inside of Easel.js. And I was able to bring our overhead for graphics rendering down by about half. And that had a little bit of a benefit. Generally, though, the main cost is pixel fill, right? The actual rendering by the browser. It's not the cost of us telling the browser to render something. Our most successful thing on the code side was we wrote some fairly simple heuristics to monitor frame rate and monitor time spent inside of each tick. And if we fell outside of certain parameters, if we were playing back too slowly, we would counter-scale the canvas. And this worked out surprisingly well. I added some simulation into this to let me show it off. So you can see what the performance looks like when I'm running it at 1x. If I reload this, so I can apply different scales to this. At 1.5x, you can maybe just barely see a little bit of blurring there. And what's actually happening is I'm basically scaling the canvas down, so I'm filling less pixels, and then I'm hardware scaling it back up. So I'm setting its CSS width and height to be larger. And browsers are really good at dealing with this. So I have 1.5x, which is almost unnoticeable, 2, which is starting to become noticeable, 3, which is getting kind of jaggy, and then 1997, which is how video looked back then. We didn't actually ever go into 1997 mode. But if I play this back now at 1.5x, I have very little loss of visual fidelity, but I'm basically going to be on target through the entire thing. And I don't think most users will ever notice this. And really, it's on high DPI devices that we're most worried about these slowdowns. And bringing it down to 1.5x seems like a really good compromise to keep this performing well. So what we did was we actually just capped it at 1.5x. We never actually scaled past that. it's interesting because the visual results of this are fairly linear, right? Like going from 1 to 1.5, it looks like, and then to 2, the visual changes are fairly linear. But of course, we're dealing with a square object, right? So we're actually, with a 1.5x scale, we're actually rendering 2.25 less pixels than we are at 1x scale. So we get a really nice exponential performance gain. The last thing we did around performance was previously Easel.js played back Flash movie clips at a 1-to-1 speed. For every frame, it would play back 1 frame. And this meant that it didn't adapt well when things slowed down. So if we started playing back at only 20 frames per second and we had authored for 30 frames per second, it would look like it was playing back really slowly. So we went in and retrofitted Movie Clip to support time-independent playback. So we could basically say, this content is supposed to play at 30 frames per second. If you're running at 60, then play a frame every 2 frames, right? Like display a new frame every second tick. If you're running at 10 frames per second, then you're going to have to jump through 3 frames every frame to keep up. And this was great. It meant that on mobile, we could play at a different frame rate, a different actual frame rate than on desktop devices and still look as though it was playing at exactly the right time. And it meant that our animation was always perfectly synced with the audio. This came in incredibly handy when partway through the project, we got handed the mandate that all of this had to be localized. We were able to dynamically time scale our content. So we could basically say, okay, our animation is 20 seconds long. We're trying to play back German. So of course, it's going to be like 3.5 minutes instead. So we can just stretch out this animation. But we found stretching it too much started to look kind of bad. So we also introduced hold points, which were just labels that our animators could put onto the timeline to indicate, this is a good place. This is a cool looking graphic. I've added in some like ambient motion, whether it's torches flickering or things moving in the background, but nothing is happening in the main animation. But it's a good holding point. So stretch as much as you can. If it's still not long enough, find all the hold points and extend them out and just hold on those hold points. So, we could take a animation that was 1:47, throw German at it, stretch it out to 252, and still have it look really good without having to redevelop any of the content. Again, something that if we had been doing video would have been really hard. It would have been reproducing all of these videos. We'd have to have versions for every single resolution and for every single language. So video. So we get to the end of the project, and we're like, yeah, we did awesome. This is so much better than if we did it with video. And then BioWare was like, yeah, and we need video. Why do you need video? Because YouTube, right? You need to be able to share these kind of clips on YouTube. So this turned out to be super easy. Flash actually has a feature that they added a version or 2 back that lets you export Flash content, including all of the running code and everything else at full frame rate and at whatever resolution you want. So all we did was we took these FLAs, we spent a couple hours rewriting our camera logic back into ActionScript from JavaScript, and we just ran all of these animations through this exporter, and we were able to deliver 1080p video that was perfectly smooth with all the audio and everything embedded, and BioWare was basically blown away. I think we kind of messed up because I think they were expecting an expensive change request, and and instead we were like, here, it's free. So the results, it ran everywhere. Console was definitely the most challenging environment that we worked on. I didn't tell you earlier, but they basically told us about console like a month or 2 before launch, which required a lot of hasty scrambling to make sure it worked there. We're able to scale performance very effectively. We were also able to build content that was designed to be performant. Completely resolution independent. We can play this back on tiny screens. We can play this back on 4K TVs. Likewise, we can adjust depending on the aspect ratios that we need. We can adjust our playback speed and use hold points to adjust to different localization requirements. And instead of having basically this huge matrix of video files, we need a 720p, a 1080p, 240p, we need English, we need German, we need Spanish, we need French, we need different bit rates. We have a single file, right? We have audio files, and then we have a single animation file. And so this has made it way easier to keep these things up to date. As they request little changes, we're able to implement them. There's no real build process or anything. I mean, there's a code build process, but we just hand them one file, they put it up, and it's all updated. And when it was requested, we were able to create video files from it all. The thing, though, that, again, I'm kind of most proud of is just this file size issue. It probably dates me. It probably means that I'm just really old. File size isn't such a big deal anymore, but when one of your primary targets is mobile, it's kind of nice when you can keep it down. And, this is basically what the file size profiles look like for video, and this is only 720p video versus the animation system that we came up with. So we're spending about 0.5 meg per minute on audio. Video, generally almost 10 megs per minute if we're running at 720p. And the animation is only about 100K per minute. And again, vector content, so it scales to anything that we need. This also made it really easy to make decisions around what we load. We aggressively preload everything because, we preload the first module. The minute we start into the first module, we're preloading the next 2 variations of modules because they're so tiny that we're not worried about using up the user's bandwidth for things that they don't want. So I thought that was pretty cool. All around, this project has been a fantastic validation for me around CreateJS. I've spent a few years of my life, not full time, but I've spent a lot of time building CreateJS. And while we have external metrics that make it seem like what we're doing has been worthwhile, it's been really rewarding to actually build a project that kind of proves out sort of every piece of the puzzle of what we've been building and showing that, yes, we can build these experiences. Not just that we can build these experiences, but we can finally do it as quickly as what we're used to doing, and that we can engage creatives and we can engage illustrators and animators to create this content without having to go through a whole lot of technical brouhaha. Most importantly, fans were happy, and this guy was happy. BioWare was super excited about how it all turned out, and that kind of wraps me up. So thank you. So it looks like I have a few minutes for questions, if anyone has any. Yes. So the question is, and I'm summarizing here, would this process be useful for the gaming industry as well, as opposed to pre-rendered cutscenes? I mean, that's obviously the way that it's gone in the 3D world. You're seeing more and more AAA games, their cutscenes are just rendered in-engine. So, 2D games, why not? I don't see any reason not. Yes? Let's see, start to end, I think we had maybe 3 months. It was pretty quick, and it was the gaming industry, so it was chaotic through the whole thing, right? You might notice that the tile set is more colorful than the animated, like the ISS, and that's because there was some pretty crazy art direction changes as it went on, but other questions? Yes? Our internal team was pretty small. We had I worked on it at the beginning because it was something that I found really interesting and I wanted to sort of set direction on it. And then we had one of our devs working on it sort of full-time through the 3 months. The animation part was a much larger component, obviously. I think we had 4 animators working part-time-ish through the whole project. Any other questions? Awesome. Well, thank you again.